Hello, this is Mrs. Garple, and in this video we're going to graph some cubic functions. And I think I might have my slide. Yep, there we go. Here's the beginning. So we're going to start with the parent function of f of x equals x cubed. And we're going to create a table of values to do this. So I've already set or selected some x values for us to use. And we're going to take each of these x values and cube them. Now when I take negative 3 to the third power, because I'm multiplying negative 3 an odd number of times, negative 3 times negative 3 times negative 3, my result will be negative, and it will be 27. When I take negative 2 to the third power, again, because it's an odd exponent, it will be a negative, and 2 to the third power is 8. Negative 1 to the third power will be negative 1. 0 to the third power is 0. 1 to the third power is 1. 2 to the third power is 8, and 3 to the third power is 27. Now, we obviously don't have enough room on our graph to plot the points at negative 3, negative 27, and 3, positive 27 without changing our scale. But I wanted you to see just how quickly a cubic function increases. It increases much quicker than a quadratic function does. What we're going to focus on from these points are these 5 from negative 2 down to positive 2. I'm going to call these my anchor values, because when we start transforming our graphs, shifting them, reflecting them, these are the values I'm going to use to help me graph my cubic function. So I'm going to start at 0, 0. Every parent function, or I should say the parent function of cubic, just like quadratic, does pass through the point 0, 0. And just as I do with my quadratics when I do my graphing, I base it from the location at 0, 0. So 1, 1, that would be 1 unit to the right of 0, 0, and 1 unit up. And then the next positive value, 2, 8, so that's 2 to the right of 0, 0, and 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Now, unlike a quadratic, instead of being symmetrical about the y-axis, we have rotational symmetry. What that means is if I rotate this portion of my graph 180 degrees, I will get the shape of the graph down here. So when I have negative 1, it's also negative 1, so 1 to the left, 1 down. At negative 2, that's 2 units to the left from 0, 0, and it's 8 down. 1, 2, 3, 4, 5, 6, 7, 8. And then we have this curve. I kind of describe it as being like a twisted parabola, because it's like we're supposed to have a parabola, but we flipped half of it down. It's not exactly the same shape as a parabola, but it's similar. It's just increasing at a much quicker rate. And this is what the basic shape of f of x equals x cubed looks like. So we're going to use these anchor values of 1 to the right, 1 up, 2 to the right, 8 up, 1 to the left, 1 down, 2 to the left, 8 down, when we graph our following transformations. So our first function that we're going to graph is x cubed plus 3. Now notice this plus 3 is happening after x is cubed. When we have an addition after something is cubed, that means it's going to shift up. We're adding to the y values that we get when we cube the x value, so we're going to shift up 3 units. Now, if it helps you, you can always draw in an imaginary axis to show 3 units above the current axis, I would just use a dashed line for that. If it is not, and again, this is just if you need that reference of where to plot the points. Since we aren't staying at 0, 0, we're actually going up 3 units from 0, 0. And those anchor values where 1 to the right is 1 up, just like it is with a quadratic. But when we go 2 to the right, we're going up 8 because 2 cubed is 8. So this is half of my curve that I need. I still need to do the other half. So when that's 1 to the left, it's 1 down. And from 0, 0, or our 0, 0 point that's been transformed, 2 to the left is going to be 8 down. 1, 2, 3, 4, 5, 6, 7, 8. And this is our curve. Let's take a look at our next one. Here we're adding 3 before we cube. That means we're going to shift to the left, because if I wanted this to equal 0, x would have to be negative 3. So this is going to shift to the left three units. So again, if you wanted to draw in that imaginary axis 3 units to the left, just make yourself a dashed line so that you can see your new reference point for 0, 0. It's where this dashed line intersects the x-axis. So this is my new 0, 0. And then we have 1 to the right, 1 up. From that initial point, 2 to the right, and 8 up. On the other side, 1 to the left is 1 down, and 2 to the left is 8 down. And we can draw our curve. In our next one, we have two things happening. We are adding, or we have x minus 4, so that's going to be a shift to the right. Four units. And after we cube, we're subtracting 5, so that's going to shift down five units. So again, right 4, I can draw a new vertical axis. Five down. I can draw a new horizontal axis to use as my reference. Plot my new 0, 0, the way it's been transformed, and use our anchor values. So 1 to the right is 1 up, 2 to the right is 8 up. Going back to that initial point, 1 to the left is 1 down, and 2 to the left will be 8. Our next transformation, oops, went the wrong way, here we go. Well, I guess that is all I have. So again, you can always draw in new axes so that you can find that origin point that has been transformed, and then use your anchor values to do your graphing. And this concludes our video.